Howdy and welcome back. So there's two different forms of the delete operator, which I know we pointed them out earlier. I just want to go ahead and emphasize that there are two. One's going to be used with arrays, one will be used otherwise. So the different forms of the delete operator. Do you notice anything different about the delete operator when it is applied to arrays compared to when we use it to deallocate other types of objects? Well, if we go ahead and just look at this code, we see two objects allocated on the stack, free store array capacity, and a pointer to an integer, free store array, who points to a dynamically allocated object on the free store array of four contiguous integer objects storing the values of 10, 20, and 30, and 40. Now we go ahead and use this, and we're now at the point where we'd like to return it so that it can be reclaimed for use with something else. Notice when we go to return it, the form of the delete operator we're going to use will have essentially a blank empty subscript directly preceding it, followed by the address of the array for which we'd like the memory deallocated for. Now go ahead and contrast this to the form of delete we've been using to deallocate memory for objects of the primitive types, or even we could apply this to objects of user-defined types. In this case, we see that free store object is an object on the stack. It is a pointer to an integer object, and it's pointing to an integer object whose space has been allocated on the free store and initialized with the integer value of 11. We've gone ahead, we've interacted with it. When we're ready to return that space or reclaim it for use with something else, deallocate the memory associated with that object, we simply invoke the delete operator. So just plain old delete, followed by the address of that object. In this case, that's stored in the free store object pointer. So why are there two different versions? Well, if we had one, we'd have to check each time delete was invoked to see whether or not we're deallocating memory for a single object or for a block of contiguously allocated objects. So by having two, we don't need to make that check each time. In the case of the first example with delete followed by the empty subscript, we know that what's being deallocated for is going to be a block of, in this case, integer objects. So we don't have to make any check to see, hey, are we dealing with an array or are we dealing with a single object? The two variations of delete are going to inform the free store manager of that. Contrast this with deleting, say, a single integer object. We don't have to check to see whether that address is to an array or a single object, because again, the form of the delete operator that has been used to perform that deallocation communicates it to the free store manager.